we have vector databases, but then there is no use of vector databases if we do not have retrieval augmented generation. Llama Index, again, shout out to the Llama Index team. They've done a fantastic job leading a lot of work in the RAG space. So, what is retrieval augmented generation? This is a technique that improves the response of LLMs, right? By pulling in relevant information from your external knowledge sources, even internal knowledge sources. When we say external here, it's external to a large language model, but it could be internal to the organization. Again, just follow me on with this whole illustration. It's beautifully explained here. Imagine you have your knowledge base. Let us take an example of, say, your own organization. You will have your website. You want to build a website chatbot. So your knowledge base here will be your web pages. Like you may have hundreds of web pages. You may have additional PDF documents, YouTube content, etc. So all of that becomes your knowledge base, and then they go through a concept called chunking, which is now, like, we are getting into the serious business. We saw a very high level view of how it works, but now we are getting into actual nitty-gritties of how it works. So the data that's coming in gets chunked. The normal default one that you would see in the market is they will get chunked into 1,000 words. Like each chunk would be about 1,000 words with an overlap of 200 words. So you forget about the overlap. So it gets chunked into smaller set, and then they started, and then it goes through the embedding models. It gets embedded, stored now in a vector database, which is what we saw earlier. So now what happens when a user query comes in? Imagine again the same scenario. You built a knowledge base of your website, of your organization with PDF documents. Now the user comes in and asks, hey, can you describe me what you guys do? What is your organization? So the user query again hits the embedding model. It The vectors are now using semantic search, uh, help us identify, or help the RAG system identify similar vectors, so closest to the user query basically. And all of that is now pulled together, what we call as top K, similar documents pulled together. Now that is passed as a context to the LLMs along with the user query. So the search results and the user query is passed to an LLM, where you have a prompt saying, hey, I want you to convert this gibberish into something readable for the user. And then the LLMs produce an output that you can verify or you can interact with. Let me show you an example using Lyzr Studio. All right. So what you see here is the knowledge base creation on Lyzr, and I have created a set of FAQs and documents, which a large list of FAQs that was shared as a knowledge base to Lyzr, knowledge base, and you can add PDFs, you can give website URLs, or just raw text. You can give various sources. But let us look at the retrieval part of it. So what happens here? I can ask the question, say okay, rather, how does Lyzr handle security? So it is now searching and it's bringing me relevant results. I wanted at least 10 chunks to be retrieved, and it's retrieving and it's showing me what is within it. Most of them are just the questions, and there will be some answers in some of the retrievals basically. So this is now re-ranked, and there are various types of retrieval that we have here, and we'll discuss about it shortly, like MMR and HyDE, etc. But this is how you can check how the data is being retrieved by Lyzr, by the RAG model, and how does it actually work in from a chat perspective. All these chunks are now passed as context. So you saw this here, the context. So this is the context. Now all these chunks are passed as a context to your chat agent. So this is actually the agent, that LLM agent that I built, and I have passed the knowledge base here. And now to this, I can ask the same question, okay, or a different question. How does Lyzr handle, say, responsible AI? So what happens? It again, the query gets passed and it is able to pull all the relevant chunks as you saw, and then it sends it to the LLM again. The core prompt is here. With that, it is able to convert and sends the output in a readable form. So this is how RAG actually works. And there are various types of RAG that came out. We started with pretty naive RAG. What you saw was basic, pretty naive one. And there is the advanced one, which is the concept called MMR and HyDE. Again, as you see here, when you go to the knowledge base, like we provide two additional options, MMR and HyDE, and there is a tooltip that explains what it is. So MMR, maximal marginal relevance, and then you have HyDE, which is hypothetical document embeddings. So MMR actually it tries to pull the more number of search results, more relevant search results without losing the context, which is what MMR does. So, which is an advanced retrieval type that you can follow. And HyDE, which stands for hypothetical document embeddings, it's even more interesting because it actually creates a possible output. Like when I asked a question, how does Lyzr handle responsible AI? Before it hits the before it hits the engine, it creates an output for it automatically, saying, okay, this is how Lyzr would ideally handle a responsible AI scenario. And then it takes that question and answer to find relevant data in the vector database. So this is why it's called as hypothetical document embeddings, because it is creating a hypothetical answer. So these are some advanced RAG forms that you could use, which you should use, to be honest, when it comes to when you move up on your agentic use cases. And then the multimodal RAG. I'll come to the agentic RAG, which is a key discussion topic today. Multimodal is where it's not only limited to text anymore. You can have images, videos are getting there, but images definitely yes. That's what multimodal RAG is all about. Moving on to agentic RAG. Again, a concept that became very popular as agents started getting popular. It's it's the concept of giving the RAG a superpower where they can reason. They can reason on how they should go about retrieving data. They can reason about what tools to look at, what data sources to look at. For example, look at this. You may have access to a graph database, a vector database, a relational database, or just documents. You'll have access to various aspects. Now, the agent, based on the query coming in, can reason in real time. It may have some examples as well to or some instructions so that it can figure out how to go about reasoning. But then it can look into various different databases and pull the relevant data. And that data will again be intercepted by the agents. This is why it's called agentic RAG because you can have multiple agents as well to check whether it is relevant to the context. If not, it can ask the original agent, the first agent, to go through the whole process all over again. But if you see the reasoning is happening within this agent RAG ecosystem, and you're able to get the output that you desire or the one that is a lot closer. So when you move away from your basic RAG or even advanced RAG, as you saw, the agentic RAG is where things are evolving further. I'll give you a real example. We are building a massive knowledge base for a research firm, about 10,000 plus documents. But interestingly, they also have a structured database like RDBMS, where a lot of client data, survey data kind of resides. Now, when they ask a question, hey, I would like to know what are the latest trends when it comes to generative AI adoption in biotech, right? This is a kind of a query that someone would ask. Now, the answer for this may be maybe in the unstructured data among those 10,000 files, but there might also be some interesting survey results that might be in a RDBMS, a knowledge source. So now this is where agentic RAG comes into picture because it starts breaking down the problem. Okay, I may have some questions, some answers here. I may also have some answers on the RDBMS side, or it can also be a graph database. And then it pulls the answers from both different data stores, and it then reasons with the one central data store with which you are able to come up with a final answer. So this is how agentic RAG actually works, and this is a real scenario that we are handling. Agentic RAG is still very fluid. There are various, I would say, uh, types of agentic RAG. What I explained was structured and unstructured data. There is little reasoning here. There could be agentic RAG where you may also pull from internet, right, like using Perplexity or Exa, any of these search APIs, and you can also consume that data to further do a reasoning. So it's an evolving space, to be honest. This is where the lines kind of blur between what an agent could do and what agentic RAG is all about. But if you have to explain in in one line, I can say that when you bring agents to take decisions about retrieving data, it becomes agentic RAG. That is a simpler explanation of how it works. It is model agnostic, it is vector database agnostic, it is agent framework agnostic. You can implement this on Lyzr or LangGraph or any other agent framework of your choice.